I would like to finish with this example of global temperature change versus CO2 concentration in the atmosphere. We're going to use the data that's given to us by the NASA climate website, which I've included for you on your handout. The summary data is that X bar, which represents the average CO2 concentration, is 353.757, and then Y bar, which represents the average temperature change, is 0.321. Then they give us the sum of the squares of the x's, which is 46,332.885. Remember, we could do this calculation in something like R if we took n minus 1 times the variance of my x data. And then they give us S sub xy, which is 486.982. We could do that by doing n minus 1 times the covariance of x and y. And they give us also S sub yy, which is defined similarly to S sub xx, but we don't need that for this computation that we're going to do, but we are going to need that later. And then what we'd like to do with this data is find the regression line and interpret the slope and the intercept. This is the way that many of the problems in the book are going to be stated for you. So we want to find our slope, which is beta 1 hat. That's going to be S sub xy over S sub xx. That's going to be the 486.982 divided by 46,332.885. That's going to equal 0.0105. And then beta 0 hat, well, that's going to be y bar minus beta 1 hat x bar. That's going to be 0.321 minus 0.0105 times 353.757. So that works out to a negative 3.397. So we now have our best fit line, y hat. It's going to be negative 3.397 plus 0.0105 times x. Okay, so now that we have that, how can we interpret the slope and the intercept? Well, let's start with the intercept. So beta 0 hat, if we're looking at the intercept, right, that's going to be negative 3.397 degrees Celsius temperature change when CO2 levels are 0 parts per million. So if there was no CO2 in the atmosphere, that's what the global temperature change would be. And then for beta 1 hat, we can interpret it as saying an increase in CO2 concentration by 1 part per million will increase global temperature by, let's look at the slope, it's 0.01 degrees Celsius on average. So if we increase CO2 levels by 1 part per million, then that'll increase global temperature by 0.01 degrees on average. Now that doesn't sound all that significant, But we should note, over the last 60 years, that CO2 concentration has increased by about 100 parts per million. And temperature has increased, global temperature, about 1 degree. And that has implications for the sea levels and all sorts of other things. So that gives us a sense of how to interpret slope and how to use that information to give us a sense of the global change in temperature over the last 60 years.